Good morning, everybody. Today we are going to continue our TP grind. Uh, let's see. Uh, so we will start with this question that's called number of ways to paint n by 3 grid, which is the LeetCode problem of the day. Why I've selected this question is I've selected to do this question today is this is a very good example of uh, application of dynamic programming and thinking about recurrences. And it's a hard problem, so I hope we will cover a lot of concepts. I was just trying to see answers for 1 and 2. So let's try to think about this problem. Let me go back to my iPad. Just finish this recordings. Okay. Let's read through the problem first. Let's see if I'm live. Yes, we are. So the question link is given. If anybody wants to solve along, they can try. Let's see. Yes, we are. So what do we have? We have a grid of size n by 3 and we want to paint each cell with red, yellow, green. We can consider red, blue, green as well. It doesn't matter. While making sure that no two adjacent cells have the same color. So either we have a conflict in the horizontal way or one in the vertical way. If you have solved house rubber 1, house rubber 2, you know that how to handle adjacent dependencies. Even though I will be solving that problem today as our TP grind continues. But we will think about how to handle dependencies. So let's go back to the iPad and let's see. Let's say this is a grid. Let's say n equal to let's say 3. In that case I have 3 cells. Now I want to fill up these cells. Like let's say I can do red, yellow, green. I think those were the 3 colors, right? Yes, red, yellow, green. Then in this place I cannot put a red. I can put a yellow or maybe a green. Here I can not put a red. I mean, here I cannot put a yellow. I can put a red or I can put a green. Here I can put a red or a yellow. And based on that, I will have a third dependency. So you see, at every cell, I am checking that what did I put on the cell before it and what did I put on the cell after it. And of course, there are ways to do this and this. For example, let's say we have only 3 colors. So either I will do a red, green, red again, or maybe red, yellow, red again. Like this, these are the 2 ways of using 2 colors at once. I can also try red, green, yellow. In this case, we have 3 different colors. Of course, these 3 can be arranged in factorial 3 ways. permuted. These three can be in factorial 3 by 2 ways because one of them are repeating. If you have studied a little bit of permutation combination in class 11, you will be able to relate. So basically the number of ways to arrange R, G and R in a 3 size row will be factorial of number of divided by number of repetitions, or factorial 2 is a better way to say that. But this doesn't really, I mean, this gets us a little bit, this gets us to a position where we have a little bit better understanding that we will be filling colors. And based on that color, we will have the next row, then the next row. We can have constraints, like every level we can do, it's an n. Let's say this is the index I. Then based on this, I can have an index I plus 1. And based on this, I can index have I plus 2. Right? Let's see. So we can have, let's say we try red, yellow or green on this. And we pass that to our next level. That what was the previous color I assigned. Okay. But let's say initially previous equal to, let's say C, which says no color. So initially I can pass that recurrence index C. Index will be of course 0. Initially I will pass 0 C, and then so it's basically recurrence index previous color, and I think, yeah, recurrence and previous color is enough. Now if and let's say I can run a for loop for I can assume that 0 means red, 1 means yellow and 2 means green. So I can run a loop from I equal to 0 to 3, 0 to 2 and check if its color is not equal to previous. We can put that color and go to the next index. The solution to this problem is much easier compared to what is trying to show. But I'm trying to help you think about how to approach this question. So at every index, I can either put red, yellow or green based on my previous index. So this is a classic way of determining, handling conflicts that depend on a previous index. For example, let's say you want to do something on this index, but if you want to do something on this index, you should know that you should not have done that on the previous index. Like alternate you are allowed to pick, so that no two adjacent sides you can pick. So this way you can either pick or skip, and pick depends on if you have skipped the previous one. If you have skipped, then you can pick. If you have not skipped, then you are bound to skip. So it's similar that if you have taken red in the previous index, you cannot take red now. Now this leaves us with, like say we have 3 colors, right? A red, yellow or green. Either I can use all 3 colors, red, yellow, green, or any factorial 3 of these permutation, like yellow, red, green, green, red, yellow. So 6 combinations. Or Or I can take a red, yellow, red. So I'm reusing one of the colors. Let's say if I have a red, yellow, green situation, how can I pick the next row? I can either pick the next row as yellow, green, red. Considering that I will, so we have either we can use 3 colors or we can use 2 colors. There is no way to form a row with only one color. Okay, so let's say we have made a 3-color row. And let's say that row is RYG. Now, in order to pick the next row, we have some options. Like I cannot put a red under red. So I can put a yellow or a green for the first row. I mean the first index. In the second index, in this here I cannot repeat a yellow, right? Here I cannot put a yellow because yellow is on top. So I can put maybe green because green does not match with the yellow. Then I can do a red maybe. But if this is yellow, if this is green, then I can put this as yellow and this as red. But this red is not possible because again, the previous one is okay, the red, this is possible. So after RYG, I can pick an YGR or a GYR. Can I pick anything else? Let's try. Like not R means yellow or green. There is no other option. Not yellow means either green or red. So let's say I try to do this. Let's say why we have trained. Can I take a red here? I think we can. So in place of R, like beneath R, I can put a Y or a G, right? In place of underneath Y, I can put a R or a G. Let's try to put so yes, so red in place of underneath R we have put Y and a G. Underneath Y I can put a green, of course. I cannot put a yellow, right? So this is a cancelled. I can either put a green or a red, but I cannot put green here. I have to put red here. But if this is red, the next one cannot be red. So green, red, yellow maybe. So you see, underneath R we have put a Y or G. Underneath Y I can put a G or an R. And underneath G I can put an R on a Y. Right? But are there any other options? Like for example, can we do a flip between these two? I think we can. Let's see. Y R G and let's say G Y R. Is this possible? No, this will not be possible because G and G will be a conflict. Is this possible? No, because Y and Y will be a conflict, like conflict on Y and Y. Can we try to switch these two? So Y, G, Y and G, R, R. This is not possible, but YGY is possible. So we are trying to think that if we have three different colors, how many ways are there to select the next row? Yes, we can do the brute force way. Like every row we are putting, we can calculate the next row based on the previous row and try every permutation combination. Yes, that is a possibility. But since we have limited colors, there are only limited ways to set the next row if we know the given row. Okay, let's forget about RYG now. Let's think about it simply. Let's ABC, let's say. Right? I can put, if this is a ABC, I can put a BCA. I can put a CAB, because there is no conflict between these. There is no conflict between these. Okay, B and C is a first possibility for the first. Let's try to see if we can make more. So maybe different. So BC we have tried. Can we try BA? No, because there is a conflict here. So BC we have tried, BA we cannot. Okay, CA we have tried. Can we try CB? No, because B and B is a conflict. So we see that if we have three different colors, there are only two ways to form this. Provided that we are using three colors. What if we have a three color and let's say we want to do a two color operation? Like let's say ABC is there. Let's say we can do a CC. Sorry, maybe a BB. You see, there is no conflict. Can we surround the world with B? Yes, because there is no conflict with A and C. Can we surround with C? No. How about surround with A? No, because A and A will conflict. So this is a possibility. Can I think of some other possibility? Let's see. Okay, is the stream running well? Okay, it is running well. Wait a minute. Is the okay. So we have discussed that if you have a 3 color, we can only do it like this. I'm thinking of if there is some other way. Like ABC is there, yes, BCA, CAB is an option. I cannot surround with A, I cannot surround with C, because if I surround with AA and CC, it will conflict with A, or if I surround with C, then it will conflict. So there are, if I decide to use 2 colors, of course there is no way to do it in 1 color because there will be conflicts. So there are 2 ways to do it with a 3 color and 2 ways to do it with a 2 color. Right? Now let's consider, let's say I have a 2 color option, like A, B, A. Now how many ways can I form the next row? I cannot put a A here. So either I can put a B, then I can put a C and A. Right? This is 2 ways. I can also do it with C. But can I put a... If I put a C, either I can put a B because it will not conflict with A, or I can put a C, but then I have to put a AC. Can I put a CBC? No. No, so then there is only one, CAC. So if I have a 2 color row, I can put the next row in 3 ways, such that it's a 2 color row. But what if I decide to cover the next row of a 2 color row with a 3 color row? So ABA, I can put a I cannot put a B here. I mean, I cannot put underneath A here. So B, C, no, B, AC maybe, right? Or maybe C, okay, I'm writing it's like this. This is a B, A, C. And can I put a, let's say A, B will be good. Can I do a BCA? No, BCA will not work because there is a conflict in at the last position. How about C and then A and then a B? Yes, that will work. Is there some other way? Like underneath B, I can put a or a C, right? If I put C here, then the other 2 will be B or A, and that will be a conflict. So only 2 ways. So we have understood that if I have a 2 color, the next row can be 3 3 ways of 2 colors and 2 ways of 3 color. If I have a 3 color, then the next row can be 2 ways of 2 color and 2 ways of 3 color. 2 ways of 2 color and 3 ways, sorry, 2 ways again, 2 color. So in the beginning, I can put a 2 color or a 3 color. If I decide to put a 2 color, the next row can either be 2 color, that will give me 3 ways, or it can be a 3 color which can be sufficed in 2 ways, right? Okay, does that match our initial condition? If n is 1, that means the first row can be either a 2 color or a 3 color. How many ways of making 2 color? 2 color, right? No, we have not calculated that. How many ways of calculating 2 colors? I think it's given in the question, but let's try to do it anyways. Like, how many ways I can form 2 colors? Okay, 3 colors, of course, factorial 3 ways. 2 colors means it can be a R, Y, Y, G or RG. This has factorial 3 by 2, so 6 by 2, 3 ways. Wait, RY means it can be RYR. Oh, there's only one way. So one way to put RYR, one way to put YGY. What about GYG? So 2 here. So 3 color, of course, factorial 3. 2 color means if I'm selecting the 2 color is R and Y, then the 2 color will be RYR or YRY. Same with a YG. It can be Y. Okay, let's go back to the iPad. So, but I'm thinking that let's say 3 color make. Okay, so the first row I can make it 3 color means factorial 3 ways. 2 color means RYR or YRY or GYG and YGY. Of course, in a similar way, RGR or GRG. I'm writing it down. So RYR, YRY, YGY, GYG, RG, RGR. So we have 6 ways. I mean 6, not 6 here and 6 here. So 12 ways of forming the first row. So 6 colorways, 6 3 colorways, and 6 2 colorways. Now let's try to calculate what for n equal to 2 will be. Like for example, if we have 6 colorways, every colorway can have either, let's see, every 3 colorway will have 2 colors, 2 ways of 2 color and 2 ways of 2 color. Wait, 3 ways of 2 color, 2 ways of 3 color. This will be 2 ways of 3 color and 2 ways of 2 color. So if I have a 3 color row, the next row can be either 2 ways of 3 color. I mean, it can also be a 3 color by 2 ways, or it can be a 2 color by 2 ways. So you see this 6 can, let's say this is 6, let's say 3 color and 6 2 color. So this 6 3 color can have either 2 3 color or 2 2 color, and this 6 2 color can have, I think, 3 ways of 2 color. So 3 ways of 2 color or 2 ways of 3 color. So how many ways? So 6 2s are 12, 6 2s are 12, 6 is are 18. So 12 plus 12 plus 18 plus 12. So 12 3s are 36, 36 plus 18, 18 3s are 54. So 54 ways. I hope that makes sense. So initially we have 6 and 6, 3 color and 2 color ways. Next row I will calculate like I can have a variable that says every branch has to be done. Like you see that in the next row, this 2 3 color can have branches. Like every 3 color will have the branch like this 3 color. Okay, let me show you. Like I know that from 1 3 color there can be either 2 3 color or 2 2 colors. So the same thing will repeat. Because every 3 color will have 2 2 branch, and every 2 color will have a 3 2 branch. Like this is a 2 color, so it will have a 3 2 branch. This is a 3 color, so it will have a 2 2 branch. Okay, so I have to find a way to calculate multiplication up to these leaves, like this multiplied plus this multiplied plus this multiplied plus this multiplied. I hope you understand. So 3 color means 2 2 branch, and 2 color means 3 2 branch. And of course those branches will have a property that 2 color means 2 color means 3 of 2 colors and 2 of 3 colors. 3 of 2 colors, 2 of 3 colors, 2 of 2 colors. It depends, doesn't matter. Next, this will continue. N is up to 5000. You understand that this will get very big, so that's why modulo has been asked, right? I can do like step by step. Like initially I have 6 and 6. Next way I will do 6 into 2 plus 6 into 2. Let's try to calculate, like let's see. Okay, this has got rotated. So initially, let's say, should I do long or int should be enough. Int, let's say 2 color equal to 6, and int 3 color is also 6. Next, for every equal to 0, I can do I less than n, maybe plus. So if n is okay less than equal to n, so for every, okay, let's say if n is equal to 2, no, I should start from 2 then. So I know that the how many 2s do I get based on these 2 and 3? Let's see. I get, I'm showing you my notes. So you see that based on this 2 column, I get 3 2 columns and 2 3 columns, 3 colors. So every 2 leads me to, okay, how many 2 colors I'm getting? That is 3 color multiplied by 2. Like how many ways I'm getting a 2 color? Like let's say initially I have some 2 color and number of 3 colors, right? In the next step, I want to know, based on these two, the same thing, how many 2 colors and how many 3 colors will I get? So in the next row, I'm thinking that, okay, initially I have 6 3 colors, 6 2 color and 6 3 colors. In the next row, how many 2 colors and 3 colors I will have? So the next row, if I want a 3 color, I can either get it from 2 colors. So every 2 color gives me 3 ways of 2 color. So 3 into the number of 2 colors in the previous row plus, so let's do this, 3 into number of, so next, I'm trying to calculate, let's next 2 color, let's say. So next 2 color will be, how am I getting 2 colors? So 3 into previous 2 colors, 3 multiplied by 2 color plus, or I can get it like 2 multiplied by 3 colors. Right? And this will be, next 3 color will be, how can I get a 3 color way? Either from the 2 colors I can get 2 ways of 3 color. From every 2 color I am getting 2 ways of 3 color, and from every 3 color I am getting 2 ways of 3 color. Of course I have to do the mod part. So let's define mod. I think I can define it here, int mod 1e9 plus 7. Right? And now I want my 2 color to be this next 2 color. And 3 color to be this next 3 color. So I'm just copying my previous answer to my current answer. So when I am done up to n, I want to know how many 2 colors and how many 3 colors are there. So return two color plus 3 color, nothing mod. The code is very simple. Okay, I have to define this. Okay, if n is equal to 2, the output is 60. Let's see. Hmm. Why? We calculated it to be 54, right? Wait, this will be 2 because you see 3 3 and okay, let's try to submit. Okay, integer overflow. Okay, we have a mod, but still overflow. Should I do individual mods? And then entire blob mod. Three mod. Okay, then this do this mod. Only 1 out of 50 test cases has passed. Okay. For some reason is the mod not working. Three into 97971. Should I try long? N is 5000, it's failing, so. Okay, so 3 into 2 column cannot be. Okay, let's take this as long. Even though shit should not be the case, like. Okay. We have a mod. Okay, accepted. I will go through my thinking once again. Does anybody have any question? You can comment down. Okay. So I will just go through it once again. Okay. So you see, there is of course one way of recurrence, that 1 2 3 then every time building it up, but it's not really required that much. Like, I can directly calculate how many ways to form the next row based on the previous row without even checking conditions. So we are checking those conditions beforehand, that we know that how many will be there or how many will not be there. uh, can we do this the brute force way, like the recurrence and the TP way? Yes, we can do it the recurrence way as well. Like this, I can, even though we have not done any iterative TP yet. This was a question. Let's try to do it the. Let's try to think about the recurrence now. Like, how would the recurrence look like? Even though we have tried to solve this completely mathematically. Like, from this we calculate this, from this we calculate this, and we went on. That's actually how tabulation works. But let's try to think of some recurrences. Like, let's say we know the answer to this. Let's say we don't know the answer to any of this. It's like from the next row, number of ways I know, but that is a problem by itself. Like I will try to get the answer for the let me help you help you understand this solution then. For those of you who are unfamiliar with ABC or don't want to look at this question in terms of ABC, you can do it with the RGB as well. I mean RYG as well. So let's try RYG. So I'm changing the notation in order to explain this once again. Let's say I have a 3-color row R, Y and G. Now I want to know how many ways I can form the next 2 rows. I mean next row. Either I can put a Y, G, R, right? Or I can put a G, R, Y. You see there are no other ways. So RYG can have the next row as this or this. If I decide to put 3 colors on the next row, if I try to decide 2 colors on the next row, that means you see we have RYG. I cannot have a R on the edge. I cannot have a G at the edge. So it will be Y. On the bottom, on the middle, I can either put a R or a G, because in the middle we have Y. So this can be the next row, this can be the next row. So you understand that if I have a 3-color row, there are 2 ways to form 3-color row in the next step, and 2 ways to form a 2-color row in the next step. Similarly, let's say I have a 2-color rows like R, Y, R. I want to know how many ways I can form the next row. So either I can put maybe I cannot put a R, maybe G, 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 and let's say R and a Y. No, I cannot put a R. I can put a G, G or an Y, Y maybe. Yes, I think Y, Y I can put. If I put a G, G, then in the middle I cannot put a Y. Then this will work. Like let's see, R will conflict with R. It will not conflict with G and Y. So in the boundary I have decided to keep G or Y. I cannot put anything else because it will conflict with R. G and Y exhaustive. And in the middle we have Y. So I can either put an R or a G. Of course we cannot put G with the 2 G's because it will conflict row wise then. So 2 ways of forming 2 colors. So if I have a 2-color row, there are 2 ways. 2 ways of forming 2 color. Or there is some other way as well. Can I put something else? Like GGYY we have tried. Can we put a YY and a R? Yes, this will also work. Can I put a GG and a Y? No. Yes. So you can put a YY and a R as well. So 3 ways to forming a 2-color row. Similarly, let's say R, Y, R. And we want to form 3-color row now. So I can put a G, R, Y, or I can put a G, Y, R. We cannot do. We start with a Y and then R and then a G. Yes, this will also work. Will there be some other way as well? No, because either it conflict with an R, so I cannot put R and I cannot put R on the outskirts. It has to be G and Y. So either it's this way or this way, and in the middle I cannot put G or Y because then it will conflict with the surroundings, right? So there are 2 ways to form 2-color, so 3-color. So if I have a 2-color row, there are 2 ways to form a 3-color row. So let's make me summarize this. So either I have a 2-color row or a 3-color row. If I have a 2-color row, I can make the next row, I think. Yes, I have a 2-color row. There are 3 ways to form a 2-color row. 3 ways to form 2-color row beneath this. And 2 ways to form 3-color row below this. Similarly, if we have a 3-color row, not CD, then there are 2 ways to form 2-color row below, and also 2 ways to form 3-color rows now. Initially we have 6 ways of creating a 3-color and 6 ways of creating a 2-color. We have calculated this like this here. Like if you have a R, Y and G, there are factorial 3 ways of arranging these. Like in the first position I have 3 options, R, Y or G. In the next position I have only 2 options because I have already used up one, right? 2 options. Like for example, if I have selected an R before, I cannot put an R now, so Y and G will be options. In the third I am left with only 1, so 3 into 2 into 1. Okay, so initially I have 6 rows, 6 ways of 2-color and 6 ways of 3-color. Now I know that every 2-color leads to 3 2-colors and 2 3-colors, and every 3-color leads to 2 2-colors and 2 3-colors. So that's what we have used. Like initially 6 3-calls and 6 2-calls, and every 6 3-calls leads me, I think, 2 3-calls and 2 2-calls, 2 3-calls and 2 2-calls. And every 6 2-calls leads me to 3 2-calls and 2 3-calls. So if I know the answer to my first row, can I calculate how many 2-calls I will get? Let's say the answer to this row is X 3-calls and Y 2-calls. It will be, you see how many 3-calls are here? 2 multiplied by x, 2x plus 2y. This many 3 calls in the next. Okay, in this case it's 6. Let's say it's 6. Then it will be 2x plus 2y, 3 calls in the next step. And 3y plus 2x, 2 calls. So exactly this we have done through this code. It's a very simple loop with some modular arithmetic. So if I know the answer, 6 and 6, so starting from 2 up to n, I calculate, that's it. Of course, the n here is given to be 5000. If it were up to 10 to the power 5 also, this would pass because it's an order n solution. There is no storing, nothing. So you can say this is a space optimized iterative DP. We will get to this as we grind through our sessions. But this is just an example of what you will try to make up or expect to be if you have achieved some sort of mastery. Even I have not achieved that. So let's see how far we can go. Okay, now let's continue our TP grind. I think we have solved up to jump game. We will continue from unique paths. I think this is the starting of grid based TP. If you have not seen the solutions from I think climbing stairs to jump game, please refer to our previous session. We have skipped one question, longest palindromic substring. We will also cover it in this session after going through a little bit up to maybe unique paths 2, or I will do unique paths 2 and maximum path sum. Then we will solve the longest palindromic substring. And there is a concept I want to discuss with you about palindromes and how to see DP as a lengthwise idea. That concept will be used in many later problems. So let's solve 3 grid-based DPs, and after that we will get into ways of solving string-based DPs. Let's see how long the session is running. It is around 58 minutes. So one question. Let's see. So you can read this question. I will give this into the chat if anybody wants to see the question, so they're welcome. Okay. Okay. To reload this. I don't know why it's running for. Okay, it's fine. Let's see. There is a robot in an M cross N grid. So the robot is initially at 0, 0 and it wants to reach the grid at M minus 1, N minus 1. Either you can go right or down. Given 2 integers, return the number of possible unique paths. The robot that is, it can reach the bottom right corner. 3 and 7 and N and M is up to 100. Okay, Let's go back to the iPad. So let's say we have a grid. Is there some tool I can use to make a grid? No. So we have m rows, n columns, and I am here. And I want to reach here. Of course, I can take a left or a right, or sorry, a right or a down. So how many rights will I take? N rights. And how many downs I will take? M downs. So let's say I have n rights and m downs. Let's consider n is equal to 50 and m is equals to 20. So I am going right 50 times and going down 20 times. So you see that it's the interchanging of downs and rights that's actually making the number of ways different. Like, for example, let's take n to be small, 2 and n is 3. So we have 2 rights. No, let's say n is 3. No, I think 2 will work. If n is 2, that means 2. Okay, sorry. We have n minus 1 rights and m minus 1 downs. Right? So if n is 2, then we have only 1 right. If n is 3, so we have only 2 downs. So I can do a right, down, down, or we can do a down, right, down, or I can do a down, down, right. So can I say that number of permutation of this string is my answer? Of course I will solve it the recurrence and DP way, but I want you to understand that, let's say this is a string. This is a string containing m minus 1 rights, downs, or let's say capital D's, and n minus 1 capital rights, R's. So it's a series of D's and R's. And every unique permutation of this string is a way to reach the bottom right. It can be TDRR, or it can be DRDR. Do you understand? So can I just say that it's m minus 1 factorial into n minus 1 factorial divided by, sorry, I should do plus, right? The total length of the string is m plus n minus 2. Total length of the string. And m minus 1, n minus 1. Because number of D plus R is m plus m minus 1 plus n minus 1. If you don't understand this formula, no worries. If you have not studied permutation combination well in class 11, or I want to refer to this as an international audience, if you know basic permutation and combination, how to count stuff, how to count arrangements, then this formula will make sense to you. If it doesn't, I will of course show you another way. Let's try to submit this first and see. if it gets accepted. After that we will solve the recurrence way as well. So I will use my, since we are dealing with factorials, this is just a, I think it's up to 10 to the power 100, so it's very less. So no, 100 means it can have up to 200, right? M plus n can be up to 200. Now of course I have to use it. I have to use a LeetCode. Within this I have to paste this combinatorics. Okay, now I can see that. Okay, comb C go back at 200 should work. And let's say we want to do factorial, right? Just normal factorial. So nothing, just factorial. So m plus n minus 2 q is equals to m plus n minus 2. That's to be factorial. C dot factorial. I think the answer is given in val, so dot val. Int v is equals to, so m minus 1 or I can just use inverse factorial. Yes, inverse factorial of m minus 1, and it doesn't matter actually, so into I can do w is equals to inverse factorial of n minus 1, and I can just say return u into v into w. Only the concept part is important, so don't worry about. Okay. Is it dot val or dot x? I think dot val should work, right? Okay, x. Okay. We do have the mod, right? Let's try modding. Let's try long. Will be easier. Let's try submitting this. Wait, so n equal to 51. The output is this. Let's not try 1e9 plus 7. Let's try int max as the. Otherwise, it can cause a little bit of problems. Well, then I have to change this mod as well. Wait. Did I use the use test case? Yes. Of course, it will be fastest. Let me now explain the recurrence and TP way. Let's go back to the iPad. So you understand that at every grid, at every position, I can go left or down. Also, at this position I can go left or down. So can I say that the number of ways to reach from 0, 0 to m-1, n-1 is number of ways to reach from this position plus this position. If I have crossed out of the grid, then the answer is 0. There is no way to reach from there. And if I have reached this position, the number of ways to reach from this position to this position is 1. So I'm saying that, let's say I don't know the answer for 0, 0. So let's say dp of x comma y is number of ways to reach m-1, n-1 from xy. So from x comma y, the number of ways to reach m-1, n-1 is dp of x comma y. Can I say that dp of 0, 0, or no, let's forget about dp. Let's say the answer for. Can I say that the number of ways to reach from 0, 0 to m-1, n-1 is equal to the number of ways to reach from 1, 0 to this end and 0, 1 to this end. Let's say I know that, let's say you can reach answer from this position in 5 ways, and I can reach answer from, okay, battery is a little low. Let me hook it up to a charger. Can I just use this? I hope this reaches. Is my camera okay? Yes. So where were we? So number of ways to reach from 0, 1 is, let's say, 7. So what is the number of ways to reach from 0, 0 to end? It should be 5 plus 7. Like either I go there and there are 5 ways to go, or I can go there, go down, and then there are 7 ways to go. So can I say there are 7 plus 5 ways to reach the end? Right? So we will use this fact. So what we will do is make a recurrence. x comma int y, and say if out of bounds, if x is greater than equal to m, and or y is greater than equal to n, return 0. Out of bounds, if x equal to m minus 1 and y equal to n minus 1, so return 1. So there is one way from reach to end point to the end point. Otherwise, return recurrence of x plus 1y, that is going down, plus recurrence of x comma y plus 1, right? So return recurrence of 0 comma 0, right? Of course I have to pass this n and m somehow. And return recurrence of 0 comma 0 comma m comma n. Let's try to submit this. Okay, of course m n I have to pass. This will probably give TLE because there are overlapping subproblems. I will tell you how that overlapping subproblems situation is there. Let's see the TLE first. Yes. Now let's try to solve this TLE. Let me show you the overlapping subproblems first. Let's say this is the answer I want from 0 0 to the end. Let's say this is 1 comma 0, and let's say this is 0 comma 1. Wait, this is 1 comma 0, this is 0 comma 1. Now you understand that 1 comma 0 will use this and 0 comma 1 will also use this. So can I say that, okay, so 0 comma 0 is dependent on 1 comma 0 and 0 comma 1. And 1 comma 0 is dependent on 2 comma 0 and 1 comma 1. And 1 comma 0 comma 1 is dependent on 1 comma 1 and 0 comma 2. So you understand that this 1 comma 1 subtree is repeated. So there are overlapping subproblems. So we want to store a two-dimensional grid because it's dependent on two variables. So we want to do, okay, I don't need the above code. So we can just say that, okay, so I think 100 cross 100 will work. Of course we will use the visited concept because we have been using the same concept because we don't want to think about default values. So we will pass dp comma vis along the way. We will check that if visited of x comma y, we return, otherwise we mark it visited. Equal to 1, and before returning we just say dp of equal to, this should work. have to pass this. Okay, wait, there should be a comma. I just formatted, so you will do this now. Okay, not the fastest solution, but this is the way. What to think about this problem? Let's go to the next question. Unique paths to. So you are given a name by an integer. Robot is initially located, and okay, so and there is an obstacle that's marked as 1 or 0 respectively. A path that the robot cannot include any of the square in the obstacle. So you understand that now it has come with a condition that I cannot cross that path. So I have to check that before taking that. So we will copy the entire code. Unique paths. So I will just rename this. Okay, I'll just use this function definition. And let's get rid of this. So you understand that before going to the next step, I just have to check that if it is 1, then don't go to that step. So I can only go to the next step. Like in this recurrence I'm calling, then we cannot go directly. So let's say if that x plus 1 comma y we don't want to go there. First it has to be within the bounds. So if x plus y is less than m I mean, now I check that, and let's say grid, right? Do I need this m and n now? Yeah, why not use it? Not an issue. I just have to recalculate that int m is equals to obstacle grid dot size okay. Now you see that before jumping, first you have to check it's within bounds, and obstacle grid of that x plus 1 should not be 1. If it is 1, then no point. Like you can just say that int raise equal to 0. I can say that raise plus equal to, like this answer will be considered only if this condition holds. Similarly, the next, and there is only one obstacle, right? Will there always be an answer? It doesn't say return -1 or something. So I am expecting that there will always expect a way. Like it will not be such a way that from a current position, this is also an obstacle, the bottom is also an obstacle. If that is the case, then the answer it will be 0. There is no way to reach. Yeah, in that case, I think if there is a entire world of obstacles, then the answer will be 0. So y plus 1 must be less than m x comma y plus 1 should not be 1. Of course, that after n there is a obstacle grid. And I just make this bigger so that you get a better idea. So what we are doing is, if the path is eligible, so x plus 1 is still less than m, so within the bounds, if it's within the bounds, then I check if it is a 1 or not. If it is not a 1, then we can consider that. Otherwise, cannot consider that. Same for going down. If I can't consider, then I will consider, otherwise not. I hope this makes sense. Let's try to run. Okay, it says too few arguments. Okay, I need to pass obstacle grid. Okay, let's try to submit. You see, this will not be possible through that mathematical way, because the obstacle grid is 1. Yeah, we have already in the m-1 and n-1 position. Of course, the return that obstacle grid of if it is not equal to 1, then only I will consider that, right? So the last grid, of course. Okay, 1 0. Of course, I cannot even sit. Okay, if I initially I cannot sit, like cannot be. Okay, it's just a bad test case, but okay. I cannot even land on the grid. It's like that. If zero equal to 1, return 0. Okay, so the mistake was that there is sometimes possible that there is no way to reach the end. Like the end may be an obstacle, like the bottom right counter may be an obstacle, or where I'm starting is an obstacle. So either if the starting is an obstacle, then I cannot even start the journey. And if the end is an obstacle, then there is no way to finish the journey. I hope you understand. Let's go to the next question. Minimum path sum. This will also be a similar, I think. Like, I have not solved this question before, but the name is itself says that it's a non-negative numbers, find the path from top left to bottom right that minimizes the sum. So it's just either from this world after going left, from that, let's say, let me show you the way. So let's say I'm on a grid. Let's say I know the answer to this, that from this I can reach the end by spending 7 rupees. And this I can reach, from here I can reach the end by 8 rupees. So of course I will take the 7 from this grid. So let's say this is X. The cost for this is X. So either at this position I will store X plus 7, or I can store X plus 8, because I am on this grid, I am on this path, so I will spend my cost. And in the end is 0, I hope. The end can also be 1. So at every position I am trying to see that either I will get, so let me just explain you a little bit more. Let's say I'm on the grid, and let's say I know that the result, I know that from here, from this position, I know the answer to reach the end is 7. That means minimum cost path from 1 0, or it's 0 1. It's 0 1. So minimum cost path. So minimum cost path from 0 1 to the end is 7. And this tells me that minimum cost path from 1 0 to the end is 8 from this position and this position. So either I can jump there and say, okay, so I am starting here, so I am paying the toll fee for this. And if I decide to jump there, I will pay the toll fee for that place to the rest of the world. So let me show you the code. Of course, I will be trying to, I will use this code again. So, of course, then it will return 0. This is just grid. Should I use the old code? No, I think I should not. I mean, I can, but too much reusing. Okay, this part I'm just, so it's just should I say that grid of so what we are doing is, if I am out of bounds, return, I have to return the maximum number, because there is no way to reach from that place to the end. If I am on the end, then I return the toll fee for that position. Of course I will mark this visited, and then I will try to find the minimum. So int left minimum is equals to recurrence x plus 1 comma y, sorry, it should be y plus 1, so it's right minimum then, comma m comma n, and int left minimum is so I will just say that return grid of xy plus minimum of this right minimum and left minimum. And this will be dp of and then we return, so 0 0 to define this m and n. Let's try running this. Okay, so okay, I have to pass and visited. Okay, I have not defined dp and visited yet. I think 100 cross 100 will work this time, or let's see what kind of constants we have. It's 200 cross 200. Okay. I'm just passing this as arguments. Of course I have to use this. Okay. Of course there is another way to not use this int max part. We can just say that if x plus 1 is less than n, then only I consider right minimum. Otherwise there is no point of considering the right minimum. So in that case also we will initialize right minimum as int max and then say right minimum equal to this if it is within bounds. If we are taking minimum in the end. Of course I can say if right minimum, if x is out of bound and y is also out of bound, I mean x plus 1 is out of bound and y plus 1 is out of bound, then for this the answer is just grid of xy, right? I mean, because that means I am on the end, because there is no left way, there is no right way. If x plus 1 is out of bound but y plus 1 is not out of bound, that means I am somewhere in the bottom. So I will return right plus grid cost if I have my y plus 1 is out of bounds. That means I'm on the right boundary. Then my answer will be grid of ij, grid of xy plus bottom minimum. No, sorry, it should not be called right and left minimum. It should be called right and bottom minimum, right? A bad name scheme. Yeah. Ah, silly mistake. So right minimum and bottom. Okay. I hope I made sense. Okay, let's see how long the stream is running. It's 1 hour 41 minutes. Now we will, from the next day, we will continue from 72 to the end, to how much we can go. We have solved this triangle part in a POTD. So we will skip 120. But before that, we will solve this question and we will understand this in depth. This will form the basis of a lot of new questions that we will solve later. Let's see if the stream is running well. I don't know why I'm not getting audio. Let's wait. Okay, okay, now I hope am I visible? Okay. So okay, let's I less than n maybe first. So it's working. So we are trying to solve longest palindromic substring. So given a string S, we want to know what is the longest substring that is palindromic in nature. So let's try to think about this question. Let's say this is a string S given. Now we want substring, so it can start from an I and end at a J, and I want to know if it is palindrome or not. Okay, so I can just run a loop for I equal to 0 to n minus 1 and j equal to I plus 1 to n minus 1 and check if palindrome from I to j. Then check then max length goes to j minus I plus 1. I hope I made sense. So this will be an n-cube solution. So for every step I check if it is a palindrome. If it is a palindrome, then I update my maximum length. I hope I made sense. Now palindrome checking can be done in multiple ways. I will teach you all those ways and why some ways are better than others in terms of thinking and also implementation. So let's say I want to return if a string is palindrome or not. Let's say I want to calculate, should be bool not. Let's say I want to calculate, know if a string is palindrome or not. There is one way, of course, string s is equals string s2 all of s. So I am copying this deep copy not deep copy, I should call this just a good copy, not just a reference. And I can say reverse s2 and return s1 equal to s2. This is one way. So just to reverse and check like ABA is a palindrome because its reverse is the same as the original. This is way one. And not a good way to think. I mean, yeah, it's a way to think. But there are better ways to think. Way two. Of course, let me just copy this. I can think that, okay, so what I will do is while, let's say int I will initialize as 0 and int j I will initialize as n minus 1. If I can just say if while s of I equal to s of j, I can just say I plus plus and j minus minus. And of course I is less than n and j is greater than equal to 0. Right? While this is the case, I can just check. Otherwise just break. So what will happen is, let's say A, B, A, B, A is given. So I will be here, J will be here. Equal, so jump, jump. Also this, I can just say and I is less than J. Equal to less than equal to J. So it will stop here. If it is A, then I will be here, J will be here, equal, so it will just cross over, right? And less than equal to, or I think less than will still work. And in the end I will check that if I is less than equal to J, then return true, else return false. Now why do I emphasize on this way? Because this is an efficient way to calculate if it's a palindrome or not. Also it gives us some concepts that if ij is a palindrome depends on if I plus plus and j minus minus is also a palindrome. And now that can lead to sub-problems. Let me show you how. For example, let's consider this string A. You understand that this and this ij is dependent on this and this. This is dependent on this and this. And this is dependent on this and this. Right? If that is the case, can I say that these two is also dependent on these two? And that is dependent on nothing as of yet. Do you see overlapping subproblems? Like for example, let me show you. Let's say there is a 4-length string. So 0, 3 is dependent on 1, 2 and 1, 2 is dependent on 2, 1. And that is also true. But what about some other string? Let's say you understand that let's say I and j are here and here, right? What if in the next iteration I and j are here? You understand that this call has already called for this, and I am calling this again based on this loop, right? Like this is a loop that will check for every two pairs. So you understand that, let's say A. So if I do for I 0 to n minus 1 and j 0 to, sorry, I plus 1 plus 1. So it will check for every two pairs. So first this will check for this and this. Then it will check for this and this. You understand that if this is known to be palindrome, then I don't need to check this part. For example, let's say I is here and j is here. This will depend on these two. This will depend on these two, right? But you understand that these two will also be used by these two. So you understand that there are overlapping subproblems. Like the same two pairs are getting accessed. Let's try to show you this directly. First, let's say 0, 0, 0, 1 will call for check for and then do. What about 0, 3? That will call for 1, 2. I think 1, 2 will also be used by. Okay, let's take this one. This will be much simpler to understand. 0, 0, 1, 2, 3, 4, 5, 6. You understand that, let's say I make a call for 1, 6. This will call for 2, 5. This will call for 3, 4. And this will call for 4, 3. And this will return because I has crossed j. You understand this 2, 5 will also be used by, or let's say this 3, 4 will also be used by 1, 6. Let's say later some. Let's say 1, 6 I have called, 2, 5 was used. Let's say later at some point I also called for 2, 5. And this will call for 3, 4. Even though I know already that 2, 5 is a palindrome or not a palindrome from this condition. You understand that 1, 6, after calling 1, 6, 2, 5 will also be called again. Like when I is here, j is here, it's a possibility. Then after that I will go here, and for every I, j will be here, j will be here, j will be here. I hope you understand that there is an overlapping subproblem of pairs. So this is the fact that we will use to make our simplification, I mean solving from n cube to n square. Okay, so of course there is a for loop, simple one. Okay, let's see. I 0 to, yeah, it's running well. So I will just max length I will initialize. Now I will take okay, let's forget about memoization later. I mean, let's keep the memoization part for later. Let's try to run this. Okay. Okay, longest palindrome, right? Okay, I have to output the longest palindrome. So I think I will take out the so I have a lot of work. So if it is a palindrome, so I will check for if j minus I plus 1 is greater than maxl, then I will cell equals to j minus I plus 1, then start equal to I don't need the end part. I can just say s dot substr start maxl. Okay, right? Okay, this will give you a TLE because we have not handled for overlapping sub problems. And also empty strings is equal to A, output is okay. I think j equal to I will also work. Yeah, even though this is just an empty test case. Yeah, because that itself is also a palindrome. Have to check for that as well. So now we will use a DP. Let's see if it gives TLE. Okay, memory limit exceeded. Okay. Maybe checking for too much overheads. Let's try to memorize this. We'll use the similar visited concept. What is the maximum length of the string? 1000, right? Mm. Okay, so memory limit exceeded. Okay, can I pass this as a reference? Okay, so that string being copied multiple times is probably what's causing memory limit exceeded. Yeah, so I will show you the code again. So what's happening is we're just memoizing, and for every pair we are storing that if I know that it is a palindrome or not, so that we don't check multiple times. And I've explained you here that why there are overlapping subproblems in uh, while calculating palindrome. This structure that shows that how palindrome is overlapping in nature and how to calculate if a string is a palindrome from I to j in a recursive fashion. I hope that makes sense. The stream, yeah. Now I will try to explain you how to tabulate this. Not necessarily tabulate, because I will make a separate section for tabulation, and how to think about recurrence, how to think about tabulation based on the references given. Should I explain this palindrome part in that section? No, no, let's keep it here only, because I want to keep all those tabulation concepts and at one place. So the next day we will start from, okay, up to which we have completed. We have completed up to minimum path sum. From next in the next grind we will start from edit distance, and we will go up to as fast as long as we can. We want to complete this medium section at least fully, and we do have a lot of medium questions, so some of the questions are hard. Okay, we have a lot of medium questions actually. Okay, we will try to do all the medium questions so that you get a good grip, and we will also do a lot of hard questions as well, because in DP hard questions are most of the times not really very hard. It's mostly about thinking about a specific concept. And yeah, there are some extremely weird questions that are marked hard and they're actually hard. Let's see if they are worth doing. We will sort by acceptance rate the hard questions, and we will only try to focus on questions that are really important for development of thinking, in how to think in terms of DP. We'll try to avoid those questions that have a specific pattern that is very rare to repeat once again. So we will try to exclude those questions, like extremely weird concept, very rare to repeat. We want to learn how to solve many questions with the minimal effort as possible. Okay, thank you very much for watching, and I will see you next on DP grind part 5. Goodbye. Like, share, subscribe. That only if you find value. There is no compulsion. Thank you very much for watching again, and good morning.